All right, ladies and gentlemen, today let's talk about lesson 7.4, which is scientific notation. So the one skill that we're working on today is the idea of using the structure of an expression to identify ways to rewrite it. So we're going to be using those skills we've learned with rewriting exponential functions, and we're going to apply them to scientific notation. So scientific notation is a number expressed using a power of 10 in the form a times 10 to the power of n, where, and this actually should be the absolute value of a, is between 1 and 10, and n is an integer. So we'll practice with what this looks like in a second. But basically, what we're doing in scientific notation is we are either multiplying by 10, in which case n is a positive integer, or we're dividing by 10, where n is a negative integer. Dividing by 10 is the same thing as multiplying times 10 to the negative power. We know that because we can rewrite 10 to the negative 1 as 1 over 10. So that's the same thing as saying divide by 10. So when we're looking at this here, we want to see which ones are in the form a times 10 to the power of n, where a is the absolute value of a is between 1 and 10, and n is an integer value. So if I look at this first one here, my a value, well, the absolute value of negative 6.237 is between 1 and 10. And the power here, positive 2, that's an integer. So this one here is in scientific notation. And these examples here you don't need to write into your notes, it's just a good practice. We'll move on to four or five practice problems that you will need to write into your notes. If I look at this one here, this one is not in scientific notation. That first term, the a term, is not between 1 and 10. So this one is not in scientific notation. This next one here, 4.2 times 10 to the 0, well, I know that 10 to the 0 is 1. So yes, this one is in scientific notation. I would represent 4.2 as 4.2 times 10 to the 0 if I wanted to write it in scientific notation. The next one, again, that a term is not between 1 and 10, so this one is not in scientific notation. The last one, well, my a term is correct, but this n here is not an integer value, so I can't say that that one is in scientific notation. But if I look at these ones here, I can turn this one into scientific notation. I want it to be 3.4 times 10 to the power of something, and I can get it back into scientific notation. Same thing here, I can adjust that a term to 1.34669 times 10 to the power of something. So I can transfer it into scientific notation. And we'll talk about how we do that and what that looks like in a minute here. So what we're going to do is we're going to practice first converting from standard form into scientific notation. And there are 4 steps that we're going to follow. We need to move the decimal point until it is to the right of the first non-zero digit. That'll give us a. So when I see any number here, I know that there's that invisible decimal point at the end of the value. And I'm going to move the number of places, n, and the direction. So I see I move 1, 2, 3, 4, 5, 6. So I need to move my decimal 6 places, and it turns into 1.220000 times 10 to the power of 6. That n value is going to be positive because my number is greater than 1. Last step is to remove those unnecessary zeros, so I can get rid of my zeros after the decimal point. So my final answer looks like 1.22 times 10 to the 6th. Well, this one here, this number is smaller than 0. So I see my decimal and I need to move it 1. Oops. My pen stopped working for a second there. Let's try it again. And we'll go to a new color. 1, 2, 3, 4, 5, 6 spaces. Well, in this case, my a value is going to be 1.3 times 10 to the 6th. Well, my value is smaller than 1, so my n is 0. What I really did here is I divided by 10 6 times to get 1.3. In this one here, I multiplied by 10 6 times. 6 times 10 times itself 6 times multiplied by 1.22. Now let's try going the other way. I'm going to take my scientific form and I'm going to turn it back into standard notation. So first thing I need to do is I need to figure out if that n value is greater than 0 or less than 0. If n is greater than 0, my decimal point moves to the right. I get a large number. If n is less than 0, my decimal moves to the left and I get a number that is smaller than 1. Then I'll insert my zeros, decimal point, and commas as needed to create my correct place value. So if I see this one here, first one, that n value is greater than 0. So I know my decimal needs to go this way. 1, 2, 3, 4 spaces. Well, I see that negative 1983, and then I have one blank spot to fill in with a 0. Next thing I need to do is I put my commas in. And so in English, we go from the farthest right and we move 1, 2, 3, comma. My final answer is negative 19,830. For this one here, my n value is negative, so my decimal is going to move the opposite direction. I'm going to move 1, 2, 3, 4 spaces, and I'm going to fill in my zeros. I want a leading 0, and then I'm going to put a 0 in each space. 1, 2, 3, and I'm ready to go. So my final answer is 0.123314159. Now that we know how to convert between the two forms, we're going to practice finding a product of scientific notation. This one is out of your homework. It's number 36. When I see this here, the first thing I need to do is I can rewrite this. What I see is 3.807 times 10 to the third times 5 times 10 to the second. And I know, using my properties of multiplication here, that I can just rewrite this as 3.807 times 5 multiplied by 10 to the third times 10 squared. And as a little side note, when we're using scientific notation, we go back to using that x for multiplication instead of the dot, just because it gets a little confusing with the decimal point dot and the multiplication dot. So when you're writing in scientific notation, I expect you to use the x for multiplication. All right, back to the math problem here. So what I'm doing here is I'm just using that property of multiplication where I can rearrange my problem, and I'm going to multiply the first piece and the second piece. So I get 3.807 times 5, which gives me 19.035 times, while using my exponent properties here, I know that this is going to be times 10 to the 5th. When I have that property rule, I add my exponents. Now the next thing I need to do to get this into scientific notation, though, is 19 is not between 1 and 10. So I'm going to need to move that decimal space one more space over. And my scientific notation is going to be 1.9035 times 10. Well, what I really did here, when I'm moving it one more space that way, I increased the number of times I need to multiply it by 10. So in scientific notation, my problem looks like this. But if I want to turn it into standard form, I can turn it into standard form from this form here, or I can do it from my original, especially if I'm wondering which direction that 10 should be changed. I can turn this one into standard form. So I'm going to move my decimal 5 spaces, 1, 2, 3, 4, 5. So I get 19035, and then 2 empty spaces to put zeros in. Count in from the right, comma, comma, and my answer in standard form is going to be 1,903,500. From this piece here or from this piece, I can see again that if I were going back to scientific, 1, 2, 3, 4, 5, 6 would get me to that 1.9. So when I'm multiplying in scientific notation, I just rearrange it. So I have a times 10 to a power, 10 to a power. Well, that's the same idea that I'm going to use when I'm dividing. If I see division with scientific notation, what I really see is I see 1.363 divided by 2.9 times 10 to the 11th divided by 10 to the 6th. Again, with my division, multiplication and division, I can rearrange things. When I do that, I'm left with 1.363 divided by 2.9, which gives me 0.47, times, well, again, those exponent rules. When I have the quotient rule for exponents, I can subtract. Uh-oh, I put a box around this, but we're not yet in scientific notation. If I look at that a value, it's not between 1 and 10, so I need to change it. I need to scooch my decimal point over one space this way, which gives me 4.7. Now what I'm really doing when I take that 0.47 and turn it into 4.7, I removed one of those powers of 10. I used it up. So now my scientific notation looks like 4.7 times 10 to the 4th. I can turn it into standard form from either way here. If I'm turning it into standard form from this way, I'm moving at 5 spaces, so 1, 2, 3, 4, 5. Ooh, green and green is hard to tell. You know what, I'm gonna try that again so I can actually see my jumps. 1, 2, 3, 4, 5. I see 2, 3 empty spaces. So I get 4, 7, 0, 0, 0. 1, 2, 3, comma. And if I want to check my work, I can check from this here. 4 spaces, 1, 2, 3, 4. That's the same as 4, 7, 1, 2, 3 empty spaces, 1, 2, 3 empty spaces. Either way, I get to my final answer in standard form is 47,000. Let's get rid of some of these extra pieces here so they're not in the way. Ooh, can't forget that one. There we go. So I can multiply and divide by shuffling around my equations so I have my like terms either next to each other or stacked on top of each other. Homework tonight is out of the textbook. 3 through 42, multiples of 3. Those are mostly just going back and forth between standard form and scientific form, and a few of the quotient and products in there. 54, 63, 64, and 65 are word problems. They're just split up a little bit differently to help you practice with these skills. And then 71 gives you one of those evaluate who is correct or are either students correct. You're evaluating the work of others. Make sure that you are writing it in the form that it asks for. Some of them ask for scientific, some of them ask for standard form, some of them ask for both. Make sure that you're following the instructions on each assignment. Thanks, guys.